Hi, I'm getting started on a new project and I wanted to document it for my buddy Ed, who's the instigator of it, and I wanted to just kind of show him what all it's taken to do it and get it online in case anybody else wants to do something similar and see how somebody who doesn't know what they're doing makes something. So the idea for this project is there's a water pump that is in his house that is used for the hot water recirculation system. That's so they have this water pump running all the time. They flip on a faucet, hot water will come out immediately because it's being circulated throughout the house all the time. But it's got two big downsides. Obviously, first, you're just wasting electricity. But the major one is that it's pretty hard on the pipes and the joints. And they recently had a neighbor whose water system had to be replaced. All the piping had to be replaced because this is awfully hard on those water pipes. So Ed thought of the idea of what if you could have a little control box where you could turn the water pump on and it would just automatically turn it off after a certain amount of time. And you could configure how long that time would be. So that was the challenge. And so I just was, kind of planning things out. And I can just show you here. So for the controller, we're thinking of just like a little box that has a knob on it so that you can switch the pump on and off and you could set the time. And inside of the controller, we're going to just run it on a battery pack so he can move it from his bathroom to his kitchen, wherever he wants to put it, just make it portable. And I thought it would be really cool to learn how to have like a battery charger inside of it. So like have a little USB plug on the side to charge up the battery pack that's inside of it. So I'm going to have a charger for the battery, and then for the microcontroller, I started looking at the transceivers. And this kind of dictated why I went with this microcontroller, this style of microcontroller that I'm going with now. It turns out that the really popular transceivers that people are using are all 3.3 volt systems. They use a 3.3 volt bus. And I was, that's no big deal. I'll learn how to do that. But I started adding up the costs of buying an 18 mega chip and the crystals and capacitors and a 3.3 volt regulator or an up converter board or whatever. And it was going to be a lot more expensive for me to put it together than to just buy one of these things. And this is what they call a Arduino Pro Mini. It's a clone actually, and it just has the 18 mega chip on it, and it has a 3.3 volt regulator built into it. And so you can get these things online for $3. And so that's why it says Pro Mini 3.3 volts here. It's because these transceivers are all 3.3 volts. So I'm going to use that particular board. It's so inexpensive. It's got the regulator on it. And I'm hoping the power draw isn't too much. It looks, from what I've read, it looks like it will be okay, but I'll have to test it out. And then for the display, I wanted to see what these OLED displays are all about. So I got one of these. It's a white OLED display, and OLED is super high contrast, and it should be sunlight readable in case they bring it out on their deck. And also at night, it's readable because it lights up as well. So it's kind of cool too because this one I chose has got a I2C interface for it. So it only takes 2 data wires, and then these are just the power wires. So pretty cool. I'm hoping that's pretty cool. Hopefully it doesn't draw too much power. And then, so that's the display. And then for the knob, I'm just going to go with a regular old rotary encoder knob, kind of like the kitchen timer uses, but without the light built into it. So got one of those guys there. And then here's the wireless transceivers. 2.4 gigahertz. They have a built-in antenna on them, and hopefully it'll work between their bathroom and their water pump area. So I got to test that out and see if it'll do it. And then on the water pump side, going to have our AC outlet, one of those USB 5-volt adapters, another Pro Mini with the transceiver. I'll probably put an LED and a button on it just so I can, if I have to do like pairing or something like that with the two transceivers. But then the big thing is the relay that will switch the water pump on and off. And so the water pump is supposed to draw 0.75 amps. So I got one of these 10 amp solid state relays, and hopefully that'll be plenty. And to switch it on and off, you just have to put high on one of your pins, and it can go all the way down to 3 volts. So with the 3.3 volts bus that I'll be having from the microcontroller, should be able to switch this on and off. And that'll be it. So that's all the parts, and I got a lot to learn, but it should be a good challenge and a fun project.